So in this experiment, we want to see how does the length of a wire affect its resistance. So if we look here, this length of a wire is going to be our independent variable. That's the thing that we need to change. Okay, and we need to measure its resistance. That's our dependent variable. And we want to kind of build from that statement just an idea of what this experiment is going to look like. Now, we've got our independent and dependent variable, and in fact, if we're changing one of these factors that we think will affect the resistance of a wire, it means we have to keep these other three things constant. Okay, so essentially I want to use the same wire. I want it to have the same material. I want it to have the same thickness, same cross-sectional area, and I also need to keep the temperature the same during this experiment, because if any of those other things change along with the length, then I won't be able to attribute the change in resistance to the length, because if I change the length and the temperature, I don't know whether it's the temperature that's caused the resistance to increase or the length. Okay, so really these other three things in our experiment then are control variables. So we're going to change the length of the wire. To do that, we're going to need something to measure with, so we're going to need a meter rule. And we'd probably increase it from maybe 10 centimeters, 20, 30, 40, 50, 60. We want at least 5 readings, maybe 6 readings is better, so we can draw a good graph with them. And then we're going to have to measure the dependent variable to find out what it is. Now, as far as you're concerned, we don't have anything that measures resistance directly. So if we don't know something that measures resistance, what we should think of is there an equation that deals with it? And we've got V equals IR, so we rearrange that and get R equals V divided by I. So if I want to measure the resistance, I need to measure actually voltage and current. So we'll do that with a voltmeter, and we'll measure the current using an ammeter. So my apparatus would look something like this. We would just have some sort of power supply. Doesn't need to be a variable power supply in this case. We would have that linked. Let's put a little switch in there as well, because one of the things we have to control is the temperature, and that's done by turning off the circuit and not allowing it to heat up. And essentially then we have a little contact here, or a crocodile clip. And what we can do is we can change the position of that little contact. So there's our little contact, and we have a wire along here. Okay, so there's our little wire. And we really want to measure the length of the wire that is in between those two little contacts, those two crocodile clips. Now, we also need to measure the voltage across that. So I could put a voltmeter, and it's probably easiest to draw it down here, like that. Okay, so that allows us to measure the voltage and current, which will allow us to determine the resistance. We then will increase the length of the wire in between these two contacts here, and that way we can measure the resistance at different lengths. Okay, and that's our experiment.